Okay, illustrative math, unit 3, lesson 1 is called properties of exponents. All right, so our goal is I can evaluate expressions with exponents, okay? So which one doesn't belong? So I always like to try to come up with a reason for all of these. For A, I would say A is the only one that's probably not true, because if I plugged in, or if I, for this one, if I do 3 squared, I get 9 equals 9. 2 times 2 times 2 times 2, that's 16. And then this is 1, so A times 1, A equals A. So I would say A is the only one that's not true, because 2 cubed is 8. That's 2 times 2 times 2. So 8 is not equal 9. So this one, because it's not true. All right. B is the only one. I'd say B maybe, because this is the only one that has a base of 3. This has a base of 2. And this is really a base of 2, because it's 2 to the 4th. This has a base of 2. So this one is the only one with a base of 3. This is the only one that's in expanded form. Okay, so it doesn't technically include an exponent. So I'd say only one in expanded form. Or without an exponent. D is the only one with a variable. All right, so they're all kind of similar in their own ways, but different as well. All right. So these are some exponent rules from Algebra 1. I would recommend pausing the video and writing them all down. Basically a product rule. If your bases match up, you can add the powers. So if I had like x cubed times x squared, you're going to add those and get x to the 5th. If you're dividing, you subtract. So for this one here, if I have like x cubed over x squared, and we usually write them as a fraction instead of a division symbol there, we would subtract those. So 3 minus 2 would be 1, x to the 1st. Power rule. If I take a power to a power, you multiply. Okay. Same thing here. If you have a product to a power, you got to take both of those to that power. If I have a quotient to a power, I have to take the numerator and the denominator to that power as well. A 0 exponent is always equal to 1. And that kind of goes back to the quotient rule. Like, think about this. If I have x cubed over x cubed, well, you should know anything divided by itself is equal to 1. So, like, if I had like 8 over 8, that's 1. Or like 3 over 3, that's 1. So we know this is equal to 1. But what if I use this rule here where I subtract my powers because I'm dividing? It's going to be 3 minus 3 is 0. And we know that it's equal to 1 because when we divide something by itself, it equals 1. So that's how I get that. A negative power means you take it, you do the reciprocal and change the sign. So a to the negative x is 1 over a to the x. And likewise, if I have 1 over a to the negative x in the denominator, you can move that up to the numerator and make it a to the positive x. And then this last one, fraction exponent, probably not going to use that today. That will, we're not going to use that today. That will come on a little bit later. Okay, so I wouldn't worry about that right now, but it's not a bad idea to have. So if you have a fraction, the top number is your power and the bottom number is your root. You can rewrite it. So, and again, like I said, we're not going to use that, but if I have like, I don't know, x to the 2/3, you can rewrite it as x squared cubed root. Okay, so find the value of each variable that makes the equation true. Be prepared to explain your reasoning. So I'm going to add these powers. So this is going to be 2 to the 8th equals 2 to the a. So now you can kind of see, oh, 2 to the 8th, 2 to the a. Well, a would have to equal 8 to make this equal. So a equals 8 for 1. This is kind of similar. I'm going to add my powers. So I'm going to get 3 to the b plus 7 equals 3 to the 11th. And then since my bases are the same, you could kind of say, oh, well, b would have to be 4. 4 plus 7 would give me 11. Okay, so b would equal 4 there. Here I'm going to subtract my powers, so I get 4 to the 3 minus 2 is 1. So obviously if this was a 1, or if c was a 1 here, we would have 4 to the 1 and 4 to the 1. Subtract your powers, I'm going to get 5 to the 8 minus d equals 5 squared. So if I plugged in 6 for d, I'd get 8 minus 6. That would give me 2. So, all right. As we move down here, I'm going to add my powers. I'm going to get 6 to the m plus m plus m would be 3m equals 6 to the 21. So if I multiplied 3 times 7, I would get 21. That way they're equal. Over here, this would be power to a power you multiply. So it's going to be 7 to the 4n equals 7 to the 20. So 4 times 5 would make this 20. So I'm going to make that 5. I'm going to add, oh, I can't add these. These are different bases. So I got to figure out here, what is 2 to the 4th times 3 to the 4th? I'm going to type that into my calculator here. 2 to the 4th times 3 to the 4th. Oops, hold on. 2 to the 4th times 3 to the 4th. And I get, so I'm going to come down here. 1296 equals 6 to some power. So now I'm going to kind of work backwards. I'm going to start saying, okay, 6 to what power is going to give me 1296? So I'm going to trial and error it until I figure it out. 6 to the 4th ends up working, okay? So I kind of figured it out with a little trial and error, okay? Because if I plug in 4 for s, 6 to the 4th is the same as that. And then here, this is going to be, let's see here, 125. Whoops, I'm sorry. 125 after I 5 times 5 times 5 equals, and then what's 50 cubed? 125,000. So if I divide by 125, I get t cubed equals 1,000. So now I can see, oh, it'd be 10. 10 cubed would give me 1,000. So t would equal 10. Okay. All right. Use exponent rules to write each expression as a single power of 2. Find the value of the expression, record in the table. First row is done for you. Okay, so this is going to be 2 to the 5th over 2 squared. So that's going to be 2 cubed. A little hard to see that. It didn't come out very clear when I copied it, and I got 8 there. This is a 2 to the 5th, 2 to the 3rd. So I subtract, I get 2 squared. That's 4. 2 to the 5th over 2 to the 4th. That's going to be 2 to the 1st, which is 2. 5 minus 5 is 0. That would be 1. 5 minus 6. So here you got to remember the negative power means you take it down to the denominator, make it positive. So that'd be 1 over 2 to the 1st. And then this would be negative 2. So this is going to be 1 over 2 to the positive 2, which is 1/4. So you should kind of notice this is a geometric sequence. You keep timesing it by 1/2. So what's the value of 5 to the 0? Well, anything to the 0 is 1. 3 to the negative 1, you flip it, make it a reciprocal. 1 over 3 to the positive 1. I don't need that positive 1 there, though. So I don't need the power of 1. I can just leave it as 1 over 3. And then here, another negative exponent, so it's going to be 1 over 7 cubed. You could leave it like that, or you could actually just take your calculator and say 7 cubed is 343. Okay, so there you go. All right, sort expressions that are equal into groups. Some expressions may not have a match. Some may have more than one match. Be prepared to explain your reasoning. Okay, so let's see here. This is going to be 1 over 2 to the 4th. So I could group these two together because this becomes down in the denominator and positive. Let's see here. Let's see here. If I subtract these, it'd be 7 minus -3. It'd actually end up being +3. So this is going to become 2 to the 10th. So let's see if I can find one that's 2 to the 10th. I don't see one. This, I add my powers. This is 2 to the -4. 2 to the -4. Oh, that's the same as this. So I could group that one together. So I'll just start grouping them with colors. Let's see here. This is 2 to the +4. So 2 to the +4 would be 16. 2 to the 10th is 1024. This is going to be, since the negative is on the outside, this is going to be -1 over 4 to the +2. This is -1 over 16. And I think if I do this, 2 to the 4th, 2 to the 4th is 16. So cool, I can group those two together. Let's see here. This one's pretty easy. 4 squared is 16. And then if I come over here, -4 squared. When I have parentheses, it's -4 times -4. So it becomes a +16. So that would allow me to group these two together. Let's see here. This one would be -16 because when there's no parentheses, it's -2 times 2 times 2 times 2. It's not -2 times -2 times -2 times -2. It's just one negative in the front. This is going to be 1 over 4 squared, which would be 1 over 16. This is going to be -4 times 4, so that's -16. I can group those together. Let's subtract these. This is going to be 2, -7 minus -3 becomes a plus. 2 to the -4, which is going to be 1 over 2 to the 4th, which is 1 over 16, which I have a 1 over 16 here. So let me get a different color. Let's use purple. That one. And that one. So the only ones I don't have matched are these two. Okay. But you're just going to kind of simplify them all out until you can get them matched up. All right, so these are pretty much the rules we had earlier. They just used B. I think we had A before, but same rules that we talked about at the beginning. So I can evaluate expressions with integer exponents. So find the value of each variable that makes each equation true. So 8 to what power equals 1? Well, obviously, A would have to be 0. Add these powers, I get 9 to the -2 equals 9 to the B. So obviously, B would have to be -2 to make these equal. These ones are a little harder. Let's do this. Because the bases don't match up, I can't add the powers. So why don't I do this? This is 1 over 5 cubed. This is 1 over 2 cubed equals 10 to the D. So this is going to be, if I multiply those out, it's 1 over 125 times 1 over 8, which would be 1 over 1,000, equals 10 to the d. So I'd have to plug in a -3 here to get it equal to 1 over 1,000. So d equals -3. Okay. Pretty much an Algebra 1 review, but it's important to make sure you know how to do that stuff moving forward into Unit 3. Okay, thank you for watching.